Just some updates on the calendar due to issues on my end and kind of things I need to get done. Our test will be on Friday this week, so we have a test on Friday this week. That will cover Firebase. That will be included in part of the test. You will see a recycler view in there as well. Authentication will not, and the stuff we're talking about today will not be on that test. So I'm going to give that some more time to settle before we test over the logins and the security role stuff that we're going to talk about today. So that will be on the next test as a heads up. Okay. So one other heads up as far as what we're working with today. We're going to be spending a little bit less time than usual in Android Studio, okay? Because mainly the thing that we're talking about today, the place we set it up, is purely in the in Firebase Console. We will use that a little bit we'll go back to Android Studio to test our application to make sure we haven't broken anything, but there's not actually any code changes that we should need to make to the application today, okay? So all of this is happening in the console. So we're going to do some coding, but it won't be Java today. Suffice to say, it's going to be a different language. Okay. So that's one heads up here. Okay. Another heads up I would give you is this. There's a lot of theory packed into this module compared to some of the other ones. The amount of code that we produce at the end is going to be pretty small. But the amount of theory that goes in it is pretty high. So I'd really, really strongly recommend you do look at all the reading assignments. So I've linked in here reading material, all those different articles. I would strongly recommend taking a look over all of those 8 articles that I've linked to. Because there's a number of things that you'll need to know about this kind of spread around. I will say that the organization of the documentation is not great. In fact, these are pretty horrible in terms of organization as far as I'm concerned. But we'll try to talk through things and put things together to kind of get you to that understanding. But just recognize that there are some things that are spread around and you might not see until, say, the last or second to last article that you read, okay, to be able to finish the assignment. Okay. So general objectives for what we're trying to do today is we want to write some security rules that are going to control access to our database. That's what we're talking about, is controlling who can do what are the things you can do with the data in our database. Okay. We'll be writing security rules about reading data, controlling who can read data. We'll writing security rules around who can write data, namely preventing users from changing or adding data that they shouldn't be able to change. So that's part of it. We'll also be limiting access to that data to, hey, you can only access your own data. You can't access anybody else's data. You can only touch your own. So for instance, I don't want to be able to have just anybody change the items that are on my library. That should only be me that can edit my library, not just anybody in the system. Cool? So that's one very important thing that we want to do. Another thing that we really wanted to get to is also we're going to use these security rules to enforce some schema constraints on the data as well. So far, things have been kind of loosey-goosey. It's a NoSQL database, so you can put in whatever data you want. There's not a schema in the same sense that you have to set up beforehand. So like if you're setting up a relational database, a SQL database, before you put any data in there, you'll remember that you have to say, here are all the tables that exist. Here are the fields that are in those tables. These fields have these data types, and you can't violate those rules. NoSQL doesn't work with that. We don't design those things ahead of time. But one of the things we can do with these security rules is start to enforce some schema constraints. There's a limit to it, but basically we say when you're trying to make a change to the database, then if you satisfy these conditions, then you're allowed to do it. If you don't satisfy these conditions, then you're denied. You get an error in your app, and it says you can't do this because you did something wrong. Cool? So it's also how we sort of enforce a schema on the data as well. Okay. So in addition to the reading material, there are also some related videos. I would definitely recommend spending most of the time with the written material, but some of these videos may help as well. The first one on this list is from that series we've been pulling a few from, the Get to Know series. This one's officially from Firebase itself. The other ones on this list are from the YouTube channel Firebase, or Fireship, which does a lot of stuff related to Firebase. So for instance, they've got one here, 100 seconds, quick introduction to security rules, which is a good kind of overview. All right, so just a warning with where we're at right now. Your application, my application, and your application is quite vulnerable as it stands, okay? You might remember when we initially created our database, it asked us a question. Do you want to lock it all down? Do you want to block all access, or do you want to allow all access? When you create the database, you have that option, and that's where it set up the initial security rules, okay? So you can tell it either block all access, don't allow anybody to read and write any data, which means that as I'm adding new collection and new data, I have to constantly go and start changing the rules. Or you can start with, let everybody do anything, and I'll figure out the rules later, which is the way that we started. We just said, hey, let everybody do anything, and then we'll stop it. So we're kind of in the process of transitioning that today. We're going to limit what you can do, which also means as we go further with this project, you're going to have more cases where you need to update the rules. Where we add a new feature, that means you got to add a new rule to allow or facilitate that feature. Cool? So if you add another collection, possibly adding new fields, you may need to come back in here. Okay. So where I say that our apps are vulnerable is that it's one thing to be wary of is the main thing that allows you to access your database is that Google services.json file. If I have that, I can connect to your database. If I don't have that, well, I might be able to guess it, pull it together, but I have to have that in order to connect to the database, okay? A common misconception is that is secure, right? We can treat it as a password, we can prevent users from getting it. We can't actually do that. So you're going to have to be wary that malicious actors are going to be able to get and extract and work with that Google service.json. There's not really a way around that. You can get that from your Android app. In fact, any app on the Android store, if they're using Firebase, I can get their Google services.json, okay? So the way that we do this, and I want to stress that I don't want you to do this on your tablets because it does require rooting them, and I don't want to go through the process of unrooting them because it's a pain. So in order to do this, you do have to root the device. The reason for that is that Android does provide some security. It's just that security can be worked around if you have a rooted device. So out of the box Android apps, Android does prevent you from reading and writing the folders where your application is stored. I can't normally do that with the terminal, but I've got super user I can. So if I root a phone, install the app from the Play Store, I can then download the APK from the terminal, so that's your built app file. I can also then decompile it. Once you decompile it, you get back basically all the Java code in it and other files that you have in it. Turns out in there, if you were to look in there, you'd find, hey, Google service.json is just a file that you added as a resource, so it's just in there as plain text. So if you've decompiled the APK, out pops the Google service.json. I can throw that into my malicious app and mess with your database all I want, right? And that's where we stand today, right? That's where we stand today. Is if you were to put your app right now on the Play Store, there's nothing stopping a malicious attacker from completely wiping your data, from doing whatever they want with your database, right? That's a big problem. Does everybody hear me with that? That's a big deal, right? So this is definitely a case where you should never deploy anything with Firebase without setting up some security rules, right? So security rules are an absolute must, okay? Similarly with the web application, it's actually, you can do the same thing. It's just easier because with the web application, you have to make that Google service.json publicly available, which means all you have to do is open the app, grab it and look through the developer tools, and hey, I have it. Now I can build my own web app and use your database to do whatever I want, right? So does everybody hear me with that, right? It's basically, if you've done any work with other APIs, usually you have this sort of API key. Effectively, that Google services.json contains all of your API keys. If I have that, then I can do whatever I want. Unlike other places where the usual assumption is, usually the assumption is, okay, I'm going to keep that API key private so that end users can't get it. Unfortunately, all those API keys have to be in the client. Because the whole point behind Firebase is it's a backend as a service. I don't have a backend, I just have a front end, right? So usually I would hide those secrets in the backend and not expose them in the front end, but because I don't have a backend, I don't have that pathway. Does that make sense? So these security rules are really what enables us to do this process, to be able to serve this up as a backend as a service, rather than having to have another API layer in the middle between the database and the front end. Make sense? Right? This is effectively what enforces the security of that backend. Okay? So yeah, thing to be wary of, if you were to deploy your app as it is, there's nothing stopping anybody from deleting your entire database. No guards against it as we currently stand. There are some things you could do to slow things down. For instance, you could try to encrypt the file and mess around with things like that. But there's nothing really, no matter what you do, there's no way to stop them. And so we want to be in the mindset of, maybe it's hard for them to get the Google service.json, but it's not going to be impossible. So we have to assume that they have the Google service.json. You have to assume whoever's attacking your database, attacking your application, has that file, and so we need to use the tools we're going to talk about today to guard against it. Cool? Make sense? I just say that to be aware of, this is not something to take lightly. This is really, really important. Okay. So what are security rules? So Firebase security rules, they're there to stand between malicious users, malicious attackers, between that and your data, right? They're standing between and guarding your app so that nothing happens that you don't want to happen. They can be very simple rules. They can be very complex rules. There's a wide variety and a wide range of what you can do with the rules, right? You can be very open to it and say anybody can do anything, all the way down to, okay, users can only touch their own data and nobody else's data. So they're a very, very, very broad range and a lot of granularity that you can get into. They use a specialized configuration language. It's not Java, it's not JavaScript, it's not Kotlin, but in a lot of ways it's very similar to JavaScript. A lot of ways it's very similar to JavaScript and JSON and Kotlin, but it's none of those languages. It's its very own language. So keep that in mind as we're looking through this. This is a completely separate, distinct language that you haven't learned before. So we have to learn that today. Okay? Also, things to note, there's a few different variants of this language that they're in use. So the one that we're working with today is the one for Firestore and also works with their storage service. But if you're using their older database has a different syntax. So some of their products may have a different syntax than what we're going to look at today. But what we're looking at today is Firestore. Okay? So some key things that this can do is that language is very flexible. So we can structure it based on what we need for our app's behavior. It provides a lot of flexibility. We can also get really granular into what are the things that are allowed to do and not do, both in terms of like, are you able to access this document or this collection, or even all the way down to, can you access and read this field, or can you write that field? We can say things like that. We can say, hey, you're not allowed to read this, and split things there. It's also important that this is kind of independent. It's separate from our app. These security rules are not actually part of the application itself. It's part of the back end, right? So we're setting them up on the back end so that no matter what happens with the application, they're always enforced. They're always run. So even if we have bugs in the application that would let the user do things that they shouldn't be able to do, that back end will be able, the security rules will be able to stand there and guard and say, nope, you can't do this, right? So typically speaking, when you get a rule valid, when the rules fail, that means you're going to get an error in the application, okay? So that means make sure that in the application, things like, hey, if something does fail, I want to report that to the user somehow. But large in part, things should kind of be built where in the application, the only things you can do in the application are the things that also pass the rules. So once you get it up and working correctly, you shouldn't see any rule validations, rule fails, but you may see some along the way. And if you're not careful, that might cause your application to crash. Okay? So just keep an eye on that and be wary that this is separate. But that's good. As I said, that means that if there's other clients out there, maybe your developer has stolen your Google service.json, they built their own app, tried to connect to your database, this will still be in force, right? This would still be in force. Or let's say you've got a web app and an iOS app and an Android app, and you don't want anything to go wrong, this will guard against bugs in all three of those apps, right? Rather than having to necessarily build those, rather than, hey, this one is misbehaving and now we have bad data or we have a data problem. So that's important that it stands outside, okay? So in general, how do the security rules look and how do they work, okay? So the way we're going to set them up is going to be through the console. The general syntax and the way that they function is kind of like this. So we start at the top, specify what service we're working with. So the name of the service we'll be working with is cloud.firestore. So cloud.firestore, or say storage if you were working with cloud storage, etc. Okay. So we're working with the Firestore service. Then we specify what resources, what paths to the resources are we matching against or applying rules for. So that would be like, what collection are you working with? Are you working with the users collection, the games collection, the reviews collection, etc.? What document in that collection are you referring to? If you've got sub-collections and sub-documents, you would work with that here as well. So you specify what path, right? What document are you working with? And then from there, you say, hey, you're allowed to do this under these conditions. So I'm allowed to read that document if blah. I'm allowed to write that document if blah. And I can get down to like, there's a few different methods that we can put in here. We can put in and say, hey, you can get a single document. We can say you can query that collection. We can say, okay, you can insert records into that collection, create records, create documents, or you can update documents, or you can delete documents. So we can get down to the nitty-gritty of even just like what operations are allowed to do. And then add conditions, say if these conditions are true, then not. In general, all of your rules are put together as or statements, not and. So if we have two rules that say this one is allowing it or this one's allowing it, if either one of those are true, then you're allowed to do it. If either of those rules say yes, you can do this, then you are allowed to do that. So if we can have multiple matches in here within that service document. And so if multiple of those matches say, hey, it's allowed, well then it's going to be allowed. Or sorry, if there's multiple, if multiple of those paths match the same thing, We'll just say, hey, if one of them allows it, then it's all allowed. So if we have things that are very, for instance, very broad, and broadly say, okay, you can read all of the documents in this collection, or you can write all of the documents in this collection, then those will take over something more granular. Okay, so that's one thing to be wary of. If you do have cases where there's overlaps, which we usually want to avoid, where two rules apply in the same case, there will be some compiler warnings that you'll see as you're writing the code. They're not errors, they won't prevent you from doing it, but they will say, hey, there is a possible overlap. Maybe you should rewrite it to get rid of that overlap. So we'll give you some suggestions. It's also worth mentioning that rules can leverage the authentication system that we just set up this week. We just set up on Monday. So it can also be based on the user that's logged in. And so that's one of the reasons why we wanted to do that first before I talk about this, is so that now we've got users logging in and users have accounts, I can work with that. So that's worth mentioning on this project. You're not going to be able to set up the stuff for phase 8 unless you've done everything for phase 7. Unless you have a login system you built in for phase 7, this stuff's not going to work. You're going to find out that your app doesn't work at all because we're doing things based on the logged in users. Okay. So, looking through general process of getting started with Firebase security. First thing that we recommend doing is starting with understanding the language, right? Because we're talking about a new language. It's good to have some basic understanding of the language before we even dive into doing too much with it. Another thing we need to do generally before we start this is we need to set up authentication. We've already done that, so we're good on that front. We also need to look at how do we define our data structure. So we've done part of that. We've kind of been building up and adding things to the database. But the way that we build that database does influence how we write the rules. In how we write the rules, we might also change how we define the schema based on how we want to write the rules. So for instance, if you've got a document and you decide that, okay, the rules for part of this document are different than the rules for another part of the document, that needs to be split into two documents. So you have, here's the rules for this piece, here's the rule for that piece. They're two different documents. If, say, for instance, maybe you have some information about your users that's a public profile and a private profile, you might need to have those as separate documents. So you can say, hey, only I can read my private profile, but anybody can read my public profile, right? So if I need that distinction, I need two documents. So that can change how we define our data. In terms of accessing and looking at the rules, the place to find them is you're going to open up the Firebase Console. I'm going to follow the link here. I'm going to go to my project, and then within the project, you're going to go to Firestore Database. And then you're going to go over here. We're in the Data tab. We've already done a little bit in the Indexes tab. But you also notice that there is a Rules tab here. So for your database, this is where you can look at and view the rules that are currently set up. So because we set up initially that everything should be allowed, this is the rules that are automatically put in here. In fact, it's saying everything's allowed until 17th of March, at which point everything stops working. So that's what we had initially set up. So a little bit of race to make sure we get here before things get cut off, but good news is that's like next week. So we're safe, right? So we're talking about it now so that we don't have to run into that problem. All right. So that's how we're going to get into here, and this is where we're going to write all of our code. It's going to be here on this Rules tab, okay? That's what we're talking about today, is entirely on this one page, okay? So, yep. Yep, I just turned it on. I had noticed that I forgot to start the stream, but it's starting now. So that's where we'll be writing those rules, okay? Things that you might want to do as you're kind of developing, you might try implementing a few basic patterns. These I've asked you to do as part of phase 8 of the project. So common use cases that come up is you might have cases where it's content only, where only you can read and write the data, right? It's maybe your private profile, your private data only belongs to you, nobody else can see it. Okay, that's one case that comes up pretty common. You also see cases of mixed access where, say, maybe everybody can read it, but only you can write it. That's another one that's really common. You might have public access for everybody to read it, but only you can only read the data that you own. Other things that come up as well, they say attribute-based access, meaning it might be based on certain attributes on your profile or on the document itself that determine whether or not it's accessible. So, for instance, you might say, hey, I've got these admins in the system, and they have different permissions than other users, right? So we might look at the user document and say, okay, based on data there, we're going to give them different permissions or permissions to do things that you might not otherwise be able to do. You also can do things like say, hey, maybe you're publishing a blog, and some of those blogs are in draft state or in published state. And so you would say, okay, these you can only read, normally you can only read documents that are published. And if they're in draft state, then the only person that can read them is the person who is the author. Make sense? So it can be based on data in the database as well. You know, it might be based on a field on the document you're editing or reading, or it might be based on a field in the user document or some other table. Once we've written those rules, you can also test them using the Firebase Emulator. I won't go into that today. That has to do with if you're trying to write unit tests, where you're trying to test the code, and you're trying to test it without using your actual Firebase instance, that's where that would come up. But since we're not really talking about unit tests, I won't go over that. And then also eventually you'll want to deploy those rules and put them out into production, which you can look at managing and deploying those rules. So where I'm mostly focused though is up here to step 5 today. So let's go on to talking about the language. Okay. Now I previously gave you a quick rundown of the language. Let me kind of run back to that. So it's going to usually look like this. One addition I need to mention is that your file is going to start with rules version equals 2. The reason for that is because the language that Firebase uses has changed, and so to use the newer features, you need to make sure you're on the newer version. The good news is if you don't go and change anything, that's already there as the first line in the Firebase console already. Okay. If you don't see that in the code samples, there's a bunch of code samples in their documentation where they forget to put that in there. Make sure that that's at the top of your file either way. But it's only going to be there once. So that just says, hey, we want to use the newer syntax features. Okay. From there, we've got the service, we've got the match, we've got the allow. Some things to mention there in terms of the allow line. You've got methods. So one or more methods can be specified here. If you have more than one method, you're going to specify them as comma separated. So like read, comma, write, or update, comma, create, etc. If you're trying to specify this for multiple methods. The standard methods that you're allowed to use break down into 5. So there's get, there's list, there's create, there's update, there's delete. And then for convenience, there are a read and write keyword or methods that you can do that group together those. So like read is a grouping of get and list, and write, it means that you're saying create, update, and delete. So oftentimes those words are a lot faster to write than writing the individual 5. Because oftentimes we're just like, okay, I don't necessarily care about the separation between those two. I just want it based on reading and writing data. Also in there, we've got the path. So that path is going to be represented as a URI. It's how do you get to that data. And then the rule is that actual allow statement you can see here, which includes the method and an optional condition. Okay? So if that condition evaluates to true, then you're allowed to do it. If it evaluates to false, then, well, maybe another rule will allow you to do it. Okay. So syntax version, we're going to have that at the top. It's going to say version 2 because that's the latest version. The service just tells us what product or service we're working with. So here we're working with Cloud Firestore. So that variable right there will be Cloud.Firestore. If you look at the console, you'll see that that's already there. So within there is where we're going to find the rest of the rules. So you can see that outer layer, the version number and the service, that's going to basically stay as verbatim. Where we're going to spend most of our time is inside of that service tag itself. Okay? Or service block. Okay. So let's talk about the next layer down, which is the match block. So a match block includes what we call a path pattern. And that path pattern is matched against the path of what the user is trying to refer to. So for instance, if I'm trying to refer to the user's collection, right, user 3, that would be my path, okay? And I can use a pattern to match that path. So I could say my path could be, I could just hard code it in as user 3, and then I'd say specifically I'm matching that. But more often than not, it might look something like this. I'd say users/user ID. So I say, hey, here's a placeholder we call a wildcard. Say here can be data here, and I'm going to just match whatever's there. Okay. The good news is then I can also use that piece as a variable further down. Okay. So oftentimes our paths will look like that, where it'd be the name of the collection / a placeholder for the ID of the document that we're referring to. Okay. So we have variables, wildcards in there. We can either match it with a single part of the path, which would be basically between 2 slashes, so it'd like be a document ID or a name of a collection. Or we can match multiple parts of the path at once if we want to say, hey, everything after users, I want to refer to that. I can do that as well. So I can either refer to one segment or multiple segments. Once we do that, these match, as I said, so user ID would become a variable that we can then reference, and we can write conditions around based on what user are they referring to, what document are they referring to, and use that document ID. And the match in general can be either a partial match or a complete match. Okay, so complete match means that you're matching the entire path. Okay, the whole path of what you're trying to get to. Cases where you might, like this be a case, these are a full match. But if I was trying to go to, say, users 3, wish list, something like this, right? Then this here, that pattern, would just be a partial match for that path, because it only matches the first part. So partial match is only matching the first part of it. Complete match is matching all of it. Okay. Until a complete match is made, your allow rules don't apply. Your allows only apply if it completely matches the path that you're looking at. Cool? So if it's like, I want to refer to this, any rule I have for users, user ID, isn't going to apply to this. I would need 2 completely separate rules to match this pattern and that pattern in general. Okay.
Does the order matter?
Does the what?
Does the order matter?
Not in terms of whether or not it's denied, because remember, if any one of them says true, yes, you're allowed, then it's allowed. So in terms of order doesn't matter because the first one will go ahead and accept it. The other side of things is it does matter because the later it is in the rules, the longer it's going to take to run that rule. So it does have a little bit of a performance impact, the order of them, and it can also have an impact on how much you get charged, how many reads or writes that you get charged, based on the order the things are evaluated. So in some sense, yes. In another sense, no, right? In one sense, it doesn't change, the order doesn't change whether or not they're going to be approved or denied, but it can change other things that you might care about. Cool? So once we've found all the rules, all those match statements that get to a complete match, we'll then go through all the allows, would then narrow and determine whether or not they're permitted. So if any of the rules say, hey, you're allowed to do this, done, you're permitted. We don't need to look at any of the rest of the rules. If none of those rules say you're permitted, that's the point where it's going to say, oh, you're rejected, you're not allowed to do this. You know, you're not allowed to make this request. So you get an error back in your application. Cool? Make sense? That's a quick overview of the matches. So an example here, zoom this in a little bit. So we might see something like this. So say, given we have the path, example /hello /nested /path, that's what we're trying as the request.path. Let's see what happens with these rules, okay? So I might start up at the top, I say match example /single segment. Okay. That's going to match as a partial match because it does match the beginning of that path, but not the whole path, right? So it matches the example /hello part, but not nested /path. Okay. So that'll match. We'll start looking at what's in here, and it will say, okay, single segment. This is this variable, that placeholder, that wildcard that I put in there. It's going to have single segment is now equal to hello, because that's where it was in the string. This rule that's here is not going to fly where it says allow write because it's not a complete match. But this one down here, match nested path, that's the combination of these two because it's nested inside of each other. This will get a complete match and we will read that rule. So according to this rule that's nested here, that's going to say, okay, the user is allowed to read. They're allowed to read that document. Cool? Or read that path. Okay. On the other side here, this one matches exactly. That's a full complete match. You'll notice here the multi-segment, you see that equal star star? Equal star star says match basically everything that remains in the path. So we say, hey, this starts with this, anything that starts with example, you're allowed to read, right? That's what this rule is saying. Is anything, if it starts with example, ends with anything else, at that point you're allowed to read it. You're not allowed to write, but you are allowed to read. Cool? And so specifically in this case, that path that we were using as an example would match both of these. They both say read, so you're allowed to do it. Okay. But the order of those rules would not change whether or not the user was allowed to read. Does that make sense? The order of those rules would not change whether or not they were allowed to read it. It just would change how much work it has to do. Right? Because it's going to stop at the first one that works. Okay? Does that answer your question that you had earlier, Evan? Mm-hmm. Okay. So single segment matches, we're going to see that as the normal. That's where you just put curly braces around it. If you need to do a wildcard, they call this a recursive wildcard, then you're going to put equal star star at the end. There shouldn't be much of any, there shouldn't be very many of those you need to do. There shouldn't be any recursive wildcards, I think, that you need to do for the lab. Because we're not doing stuff with subcollections, there are less likely to come up, if that makes sense. Okay, next up, let's talk about the allow statement within that. So the allow statement is going to appear within a match block. Match block can actually have multiple allows, not just one, but it always has to have at least one. And these are what we consider the actual rules. The actual rules are those allow statements. Yeah, the match and the service tags matter, but the main thing we care about is what are those rules that you're actually trying to meet. So the conditions on the allow, again, they have to evaluate to true for the user to be allowed to make the request, whether it be inserting a record, updating a record, reading a record, etc. It is possible to write those statements without conditions. So for instance, I can just say allow read, and then unconditionally they are allowed to read as long as they're looking at that path. Okay, as long as it matches, then they're allowed to read. Similarly, I could say allow write, and they're just allowed to write with no conditions. Okay, so in some cases I might want to do that I might want to say, hey, the user can read everything in the they can read everything in the movies collection, so I might say allow read on the movies collection. Make sense? Also in there, let's see, where was I at? As I said, if any of the rules allow it, then it's allowed. So broader, if you have a broader rule that says anything under the scope is allowed to do it, your more granular rules don't really matter. They're going to be ignored. Okay. So an example of what this might look like is where maybe you have, this is working with the storage, Firebase storage, but it kind of applies to the database as well. With storage, you might say, hey, the user can freely read and delete any of their own files, but we might also want to add some more granular of like, well, what kind of files can they work with? So in this case, we've got two sets of matches. This first match says user is user ID, any user file. So anything that's located under my user ID, like my specific user folder, I'm going to say, okay, you're allowed to read or delete files within there as long as A, you're logged in. So if you're logged in, with your request.auth is basically your login status. Okay. If that's not null, then you're allowed and you have to have the right user ID. So the request.auth.uid, which is the ID of the user that's logged in, has to match the user ID in the path. Does that make sense? So I've got two conditions here on that one rule, one allow.
Actually, the way the code's written right now, we're only targeting it with the Firebase auth.id's user ID, right? Mm-hmm. So the code itself is preventing us from targeting any other user ID's collection, but here this is for
it's preventing you as long as you're in your app and your app is working. But you're presuming that there's not somebody else who's stolen your Google service.json and can do other things.
Yes, that's what this is for, right?
Yes, this is under the assumption that first of all, there can be other malicious apps out there that somebody could make with your credentials. You want to block that, and you also want to avoid accidentally flubbing something in your app that allows them to write something that they shouldn't be able to write, right? In theory, yes, because you've already guarded those things, those cases that aren't allowed shouldn't be happening. But there are other cases where they could be, and we need to do that for security purposes. Okay. So we're trying to block things, yes, that shouldn't be happening in the first place. That is correct.
Okay.
But just blocking it in your app is not sufficient. We have to set up these to be really secure. Okay. So that's going to say, okay, anything that I own, any file that's under my directory, I can both read it or I can delete it. That's fine. Next rule here says, okay, user ID, if it's in the image ID folder, so specifically looking under my images folder, those files I'm allowed to write as long as three things. I'm logged in, that's my folder. And the image that I'm actually referring to is, it ends in .png. So if it doesn't have the .png extension, then I can't write it. So that means basically all this is allowing us to do is I can upload or modify PNGs to the images folder. I can read any of my files and I can delete any of my files. But I can't upload, say, a PDF file. Make sense? If a PDF file was already up there, I could read it or I could delete it, but I can't upload a new PDF. Cool? And you can kind of see how you can layer rules together to allow this is allowed, this is not allowed, and kind of create an interop with that. One thing to note, because delete is also part of the write shorthand convenience method, this actually matches both of these match for delete. In the delete case, both of these rules would get executed. But per this one doesn't check the file extension. So if it's a PDF, I would be allowed to, because this one would say allow, even though this one would say you're not allowed. Does that make sense?
So you're saying if there was some way there was a PDF
So
there instead?
if there was already a PDF there, this rule here would not allow you to delete it, but this rule does allow you to delete it.
Okay. Is that what you want?
Which is what we want.
That's what you want, okay.
Yeah. What we're trying to create here. Also means things like, hey, maybe we decided at some point, maybe we were initially allowed JPEGs and now we don't allow JPEGs. You can still delete your JPEGs, but you can't upload new ones.
Okay.
So the general methods, we kind of talked about this a little bit already. Read is to allow any type of request, get and list. Write is to allow any type of write request, create, update, delete. Get specifically means that you're talking about getting a single document, right? So remember, if I do like collection.document, then I'm saying I want a single document. On the other hand, list is any query I want to do, right? So if I want to get the entire movies collection, or I want to get some of the movies in the database, both of those would go against the list method. Make sense? So get is I want a particular document, list is I want, here I'm going to run a query. Right. Crate is anytime we're inserting a new document, so it's not there yet, we're putting a new one in. Typically we've been doing that with the set, but it's worth mentioning that set is create or update depending on if it already exists, right? So if it's not there, then you're creating it. If it is there, then you're updating it. So that set could be either create or update. That's a thing to watch out for. And then delete is obviously I'm deleting one or more documents. So then I can say, okay, you're allowed to or not allowed to delete this. Okay? As your queries get more complex, you can keep writing things the way that we've seen. It's also possible to write functions in their query, in their syntax. So for instance, we can say, okay, well, this is some code that I keep repeating. Rather than repeating it, let's make a function. In the syntax, they're very similar to JavaScript functions. They actually use the function keyword. But they are a little bit different because they're not really JavaScript. They're just similar to JavaScript. So for instance, functions have to include a return. That return has to return true or false. Has to be true or false. It can't return a string. It can't return an object. It has to return yes or no. Okay. In those functions, they can access other functions. They can access any variables you have in your scope. They are not allowed to recurse, as in call themselves. So you can't have recursive functions. Those are not allowed. And there is a kind of a tight limit on how tall that call stack can be. You can only call up to 20 functions. If you're anywhere close to that, you might want to re-engineer. But because large in part, it's more helpful to have these functions be more independent. Usually I find, rather than calling those other functions. As of version 2 of the syntax, assuming you have that rules version equals 2 up the top, you're also allowed to use the let keyword within functions. which means you can have variables. You can say, hey, let this be equal to this expression as a way to make things shorter, as a way to kind of shorten the code and not have as much on one line. It also lets you give you some names, but there is a limit on any function up to 10 lets, up to 10 binds. Again, hopefully you're seeing the point of functions is they're supposed to be they're much simpler. They're quite a bit simpler than what you would normally see in JavaScript or most programming languages, but you're allowed to use them as a shorthand. Functions are defined with function keyword, and they can take 0 or more arguments. They can actually take arguments if you need them to. So some examples. Let's say we have this case where you've got documents, and we want them to be accessible if either you're signed in or if they're marked as public. Okay, so we're writing a function here, function signed in or public. This is going to return true if one of those two things is true. So we're saying request.auth does not equal null, kind of the same syntax that we've seen with say JavaScript, other languages, or resource.data.visibility is public. When you see that resource variable there, that's referring to the document that you're trying to change. So we're saying document.data, that's the data in the document, and then we're looking at a field in there called visibility. So if I was going to look at it in the database, this would have a field named visibility, would be either public or private. So if that's been set to public, then you can read that document. Okay. So rather than duplicating that code in multiple places, they're writing a function up here and then using it for both of these roles. So we're saying any city, you're allowed to read and write it if either you're logged in or that city's been marked public, or you can, with users, you can read and write that if either you're logged in or it's been marked public. Cool? Make sense? So if you're not logged in, you can only access the public data. If you're logged in, then you can access everything. Is the way that one's set up. Another option, another case we might see here is an example. Here's a function that accepts two parameters, a user ID and an article. You can see that here between the the parentheses. And then we're using two parallels. So we say is author. We're going to check if the article's author is the user ID. So if you are the author, that becomes true. Otherwise, it becomes false. Here we're also checking if they're an admin using a bit of interesting syntax. So the exists function just checks if that document is there or not. Okay? So we say, is this document there? Now the document that we're looking for is under databases / the name of the database that we're working with. That's what the the $sign thing is. We're putting a variable in there. Documents, admin, and then looking by the user ID of the users logged in. So we're saying if there is a document under documents admin, basically, then yes, they're an admin, they're allowed to do this thing, right? So this might be a way where you might want to use some parameters, you might want to use some lets, rather than trying to write that all in one function. One of the downsides of writing it this way is that it's not taking advantage of short circuiting. So regardless of whether or not they're the author, I'm always having to do this read into the admin table. I'd probably not want to do that if they're already the author. There's no point in me doing an additional read. So one way to get around that and make sure we're doing the short circuiting is to break it down into smaller functions. So if I say, hey, let's make an isAuthor function that just checks if they're an author, I make an isAdmin function that just checks if they're admin. That makes the code a lot easier to work with, makes it actually a lot more reusable. But then I can combine those two functions here, function isAuthor or admin, and it takes in same parameters, but I just say isAuthor or isAdmin. The beauty of this is I don't have to call the isAdmin function if isAuthor returns true. Make sense? Because of that short circuiting, which means that I don't incur a read that I have to pay for on the admin. Cool? Because when you're doing things like this where you're reading another document, you can incur additional charges for reading. Okay? So that's the basics of the condition, of those kind of syntax. So last up, let's talk a little bit more about the conditions. Remember, the conditions are going to be these Boolean expressions. So they're the parts that appear after the if. They decide whether or not the thing should be allowed or denied, the request. They're also oftentimes in there we'll use the request variable and the resource variable, and you've seen this already in some of those examples. So the request variable refers to the operation that the user is trying to do. So common things we will use on there is like request.auth will tell us about the user that's logged in, whether they're logged in or not, or request.auth.uid will tell them who they're logged in as. Request.method will tell us what the method that they're requesting, so like get or list, etc. Request.path will tell us what part, what resource, what document are they referring to, so we can use that variable as well as we need. And then finally, the resource variable contains information about the document that we're actually accessing. So we can use that. It's set up as a map of key value pairs to kind of see, okay, what's the data that I need. Just to mention about cost, if you're referring to the resource variable in any of your conditions, that will necessitate a read on the actual document, even if it's denied. So if you decide to deny a document, but you had to refer to the data in that document to make that decision, then it still counts as you having read that document, even though the user didn't get a response back. Just a big heads up there. Cool. That's usually a case where we need to do the read anyway, so we'll go ahead and take the hit, but it's worth mentioning that. Operators that you can use indexing operators with the square brackets. If you have arrays in your data that you're referring to, you can use the parentheses anytime you need to call functions. You can do like a.f if you've got properties that you're trying to refer down further into objects or maps or whatever it may be. The not operator is available, the division operator, the modulus operator, times, plus, minus. So most of the operators that you expect, they're all available there. Same thing with comparisons, less than, greater than, less than or equal to, not equal to. So they're basically the same sorts of syntaxes. I might refer to these ones real quick. So A and B, if you see that one, try to remember what that does. Existence. So if you need to check if something is in a list or a map, if it exists there, then you can use the in operator. If you need to know something is a certain type, you can say, hey, this is a string or this is an integer. If you need to do, again, comparison, there's also ands and ors we've seen. And finally, there's the ternary syntax. So for the most part, those should all be familiar. They're the same operators that we saw in JavaScript. It is a more limited set than JavaScript, but all pretty familiar operators. So that does make the syntax a lot easier to learn because it's similar to what you've seen before. So looking through some of these, occasionally you may need to, oftentimes we may want to tie in and use the authenticated user as part of our conditions. So you saw already that I can do request.auth to check if they're logged in or not, just check if that's null. I can check their UID, which is the most common thing we care about, so request.auth.uid. If I need their token, I can get that. That would be their JWT token. I can also refer to like what's their email address, is their email verified. You can change things based on that, phone number, their display name, their says users Firebase UID. I'm not entirely sure what that is. Yeah, so there's there's a few other pieces that you can refer to should you need that information. So some examples that they give here is this is a really common one where you might say only allow them to read and write it if they're logged in and they're referring to a document that belongs to them. So here there's users, UI, user ID. If that's the case, then they're allowed. Otherwise, they can't access anybody else's user account.
So you need to check that they're logged in when request.auth.uid should inherently mean that they're logged in?
You're always going to do this to check if they're logged in.
Okay.
Yeah. Don't make the assumption on that. So we only want to read down into further into request auth if we also previously know if it's null. So always preference.
Oh yeah, that's right. Sorry.
Yeah. Assume that if you're going to do this, then you need to check that it's null first.
Mm-hmm.
In some cases, you may have what they're kind of referring to here as specific or extra user information. So in this case, we may need to refer to other fields that are defined elsewhere or more parts of their profile. So here we're checking they can write if they're logged in, and we're going to go do a go get a document from somewhere else. So we're looking at go to the database, go to the user document, go to their specific user document, and then within that document see if the admin field is true. So we might refer to other fields such as a role to say, hey, let's check their role. If their role is editor or reviewer or whatever it may be, then they're allowed to do this thing. So those things can come up as well. Anytime you're looking at these, do notice that there's some examples. So notice that there's tabs, so like real-time database, cloud storage, because sometimes there's a different code example depending on what you're looking for. So make sure when you're looking at these examples, you're looking at cloud Firebase syntax. Okay. So common security rules that come up. Locked mode. Let's say we want to, when we create the database, remember we had two options, fully open or fully locked. If I want to say you can't do anything, this is one way to write that, is to say, okay, database documents. Okay, so that's going to match any documents in the database. We say, you're not allowed to do anything, basically, is what that's going to say. Is because it's false, well, that's always false. So if you had picked the other route, that's what it would have put in there as the default, if we hadn't said it was by default open. Similarly here, this one's going to allow it for anybody to do anything if you're authenticated. Okay, so let's kind of look at, so you can look further into there. There's a bunch of examples that they look at. This is a good place to look for if you're seeing some common patterns that you see. But let's work our way back to here. So now that we've got some of the theory, right, you can kind of understand how we write the rules, right? You can maybe see that there's a little bit more to the syntax, so definitely recommend looking through some more of the writing. We can start writing our own rules, okay? So let's start with what we have so far, okay? It's referring to rules version 2, that's good. We're referring to Cloud Firestore. We're saying database documents, okay? So we're talking about the documents. Now, what we want to do is we want to set up the rules to be based on the different collections we have, right? Make sense? Mm-hmm. So I'm going to say based on, this collection is going to behave this way, this collection is going to be this way. That's where I would start, right? So if I look at the tables that I have, okay, I've got movies, I've got genres, I've got movie vote, and I've got a reviews table. I would probably start, going through those collections one by one and trying to figure out what to do there. So let's say we start at pulling out that. We're going to say match, and maybe match on genres. Okay. So I'm going to match on genres. Now, what are some of the rules and behaviors I would expect for genres? Well, who can read the genres? Who's allowed to read the genres? Are there any restrictions on who can read the genres?
Were we doing any reads on the genres?
We are. Where do we read the genres?
Oh, that's to build the spinner.
Right. Build the spinner. So to build the spinner, I am reading the list of genres and using that to populate. So inherently, everybody that uses my apps has to be able to read the list of genres. Right? Does that make sense? Mm-hmm. So I need to say allow read. I could be more specific and just say allow list, because the only operation I'm doing there is list. But I'm not really worried if somebody tries to read a single genre. No big deal. So I'm going to just say that allows all reads. On contrary, what about writes? Should people be allowed to write the genres collections? Not really, right? The only people who are going to modify the genres collection are going to be developers, right, or administrators. So it's worth mentioning that these rules don't apply if I'm just coming into the console and making changes here myself. These rules only apply when you're coming in from the application side. Make sense? So they're not going to stop me from changing data on the genres. They're just going to stop me from changing data in the application. Okay? So I can do that for genres. What about the next step would be, what about movies? I think maybe here I want to do for both of those, I think I want to do genre ID / movie ID. Okay. Who's allowed to read or view the movies? Who's allowed to read the movies? What are the conditions there?
So is that something you want to allow anybody to do, or only the people that are signed in?
Probably anybody, right? Because if I were to think, like right now you do have to log in to get into the app, but I really don't care to block anybody. If I were to later want to put in anonymous and say, hey, you can start using my app without creating an account, wouldn't really be a problem. So I'm going to go ahead and say that anybody can do that even without being logged in, because I don't really care that people are logged in to do that. Similarly, when we're talking about movies, right, I've also set this up in a way where, well, my end users are not changing the movies. Make sense? So the only thing I'm going to allow for that collection is that they're allowed to read it. Next one would be the movie vote. New tab. Make sure I can look at this side by side. So for the movie vote, match movie vote. This would be the vote ID. Now, it's worth mentioning that even though what I've used as the vote ID is a combination of the user ID and the movie ID, I can't split those. There's no way for me to split those into two tokens, just so we're clear. I can't say here, let's split that into two variables. So the vote ID is the entire thing, both of those things put together, including the semicolon. So in terms of the votes, who should be allowed to read the votes?
who should be allowed to read the votes? Well, it depends on what you're trying to build, right? If one way to go around it, there's two common cases where you might see. You might say, hey, nobody else should be able to see my vote, so it should only be I can read the votes that I have made, is a common case. Another common case might be that the only people that are, or that anybody can read the vote if maybe on the user profile you have a way to see, hey, here's the votes, maybe it shows all the movies that you've liked. Then you might do something different, right? But I'm going to say for this, because it's more close to what we're going to be doing in the example, I'm just going to say, I'm going to leave reading open. I'm going to just say, for this purpose, I'm going to say, hey, anybody can read it, okay? They can maybe see my likes and my dislikes. But I want to, on the other hand, I do have users changing this, so they're not necessarily able to change this under any condition. I need to be more specific about that, okay? So the other two collections was pretty simple. I could just say, hey, you can't read genres, you can't read movies, or you can't write to either of those collections, but I do need to allow the user to sometimes write to the votes, right? So what are the conditions? What things have to be true in order for me to be able to edit a vote or cast a vote?
You need to be logged in.
You need to be logged in. So how do we check if you're logged in? You remember how we check if they're logged in? Auth. That's part of it. What's the rest of it?
Request.auth.
Yep, request.auth. And we need to check if that is not null. So request.auth, if that's not null, then we're logged in. So that will prevent users that aren't logged in, but I still need to check that I am the person who cast that vote. Make sense? So I still need to add some more stuff to that. I'm going to bring this down because otherwise there's too much going on there. Boop. So other conditions I need to look at the user's ID and compare that to the user that's on that vote. Make sense? Yeah.
So I understand if it's pre-existing,
Yeah.
comparing it to the user ID that's there.
Yeah.
But how does this work for writing a document that doesn't exist yet? How can you
So
guarantee?
that's a good question. So there's two pieces. You can look at the data that they're updating it to, and you can look at the state of what it is currently. Okay, so we can either look at, what are we changing it to, or what is the current value of that thing. Make sense? Okay, so if I'm looking at that, if I say resource, remember resource is the document we're updating. From resource I can say, let's look at the ID of the document, or we can look at the data inside of the document. Within that document, remember that I have a user ID field, right? So this would say I'm only allowed to write to it if I am the owner of it, right? In fact, this would be better served under the case of update or delete, right? If we're updating or deleting a document that's already there, then I have to be the owner of it, okay? Because creating might be a little bit different. Allow create if the user is logged in. So request.auth is not null. And I need to similarly say, hey, you need to have a particular user ID. The difference here for creating, I'm looking at request dot, I think it's request dot resource dot data dot user ID. So if I'm looking at request.resource.data user ID, that's what it's being changed to. That's what it's being set to. Versus this over here is what it currently is. In fact, actually for the update and delete, the update case, I might need to specifically say also that you're not changing it to something else, right? So oftentimes it ends up being, hey, maybe we need to be a little bit more careful. If I want to be really careful, I would say because we've got that as part of the document itself, there, that would be that. And this one in the middle would be both. If you want to be extra careful, that's what we would do. Is we would say, okay, in the case where you're creating, that user ID that you're entering has to be your user ID. In the case where you're updating, it has to already be your user ID, and you have to be changing it to your user ID. Make sense? And it has to be becoming your user ID. You can't change it to somebody else's user ID. In the case where you're deleting, all I care about is that it belongs to you. Right? Sometimes we want to get more fine-grained with that to prevent things like this. If we split it up this way, that does prevent it from being altered or changed to being owned by another user. Make sense?
That makes sense, yes.
So that's the way to be really, really specific. Other approaches that I went through can work if you're less concerned about being hyper specific about it, but that's kind of the safest way to go about it. Okay? Make sense? All right. So let's say we're talking about reviews. If I want to do the same thing, let me go ahead and publish this as we've got it, because I've started to make some rules. I haven't saved them. So I'm going to go ahead and publish the rules that we have so far. Okay. It says can take a little bit to propagate, will be applied. But so I've tested those rules. A good thing to do would be to go back to my application and see if those rules are maybe working as expected. So I might want to go and check that I can still read movies, that I can still read genres, that I can still read or modify the votes. So I want to pull up my app now in Android Studio and do a little bit of testing with what we've got so far. When Android Studio boots up. Any questions on this syntax particularly? Remember when we were doing third semester, we were setting up all the middlewares and stuff, authorization header. Basically, this is the equivalent of that. Yeah.
Like a user library.
Uh-huh.
User wish list.
Yep.
Would it just be like the library ID then? Or
What do you mean the library ID?
then you say like match user library call user ID?
Oh yeah, that's a good question. So those names there are just
Uh-huh.
semantic, right? They don't actually, they're for our use. It has no clue what it's called, right?
Has no clue what's called.
The MIDI ID, the mode ID, the genre ID. We could name them whatever we wanted, right?
Yes. Yeah. These names this is the name of the collection. This is just a name I've grabbed,
Okay,
right?
okay.
This is just a name I grabbed. So that as though it's going to be the document ID. Whatever the ID of that document is what's going to appear there, right? That user ID here that I've got here, I'm presuming that I've got a column or a field in the database called user ID, right? So there are some assumptions, there are some names here that I've built in because of how I've named things in my database. So if I go to movie list, I'm going to pull this up. Because once you publish these rules, you need to go check and make sure that things are still working. One fair forewarning, remember you're dealing with security. Unfortunately, you'll get errors if the rules are too restrictive. You won't get errors if the rules are too loose, okay? So if you're allowing something through, allowing something to happen that you shouldn't, just a heads up, you are not going to get an error for that. So those are things you just have to kind of work through, and you may have to do a little bit of playing around to figure out what you need and what you don't need. Okay, I'm gonna hit run. What?
That's it. I got a snack bar that told me there was an error while getting my movie votes, but I did get them.
Okay. Well, it may have been, the error may have been it couldn't get it from the server, but it still pulled it from your local cache. So one thing you may need to test in order to fully test this out, you may have to like clear the storage and then test it, because otherwise, yeah, you can get some false positives for it telling you when it's working, but it's not actually working.
Mm-hmm.
And so I definitely need to do that before I go too much further in here. So I'm going to go ahead and go to application info. Oh, I meant to clear storage, but that's fine. Uninstall. That will have the same effect.
Still got them, but it still gave me the error.
Okay.
I'll figure it out.
So I uninstall it. I'm waiting for it to go. Here we are. Sign in with email. Log into my account. It's taking its sweet time. Go ahead and get logged in. Make sure. Is there anything in logcat? Yes. taking a very long time to connect.
Just an aside.
Yep.
The recruiter from Doherty wants to get in front of your class virtually.
Okay.
So we'll set up a maybe 30-minute virtual Teams call one
Okay.
afternoon, if you like. 12:30 to start a class.
Yeah, sounds good.
Okay.
Sounds good.
We'll touch base later.
Okay, good. I'm gonna delete my account. Try to register a new one. That's very interesting. Why is it not getting out to the internet? I'm going to go ahead and wipe the data on the emulator. Try the other one. Should tell that one to go ahead. So, if you want to get up and stretch your legs, I'm having a little bit of trouble getting my app up and running. There, it finally ran. Let's go ahead and take a quick 15-minute break. We'll come back at 2:20. Alright, so I got my app up and running. We have a chance to stretch your legs. When you see I've got the app running here, it started up without any problem, so I was able to get all of the genres, and you can see them in the drop-down list. So those are being populated successfully. You can see the movies being populated, and you can even see that it's pulled in my votes, right? So you can see them being displayed there. And I can also try to edit those, so like I can try to cast a downvote that would trigger an update, and that update's going through, or I can delete, I can add. So all three of those operations are working as I expect them to. Cool? So let me do a little bit of testing to kind of show you what happens when those things are not set up rightly. Okay, so if I go back to the database, back to my rules, I'm going to comment all the rules that I just wrote. Okay, so I'm going to turn off all of those things that are allowing the user to have certain permissions. I think it's actually not allowing me to do that because I need to comment out more there. I'm going to just need to comment out. Let's see if I do this. // let me try to publish that. Okay, so it must contain at least one declaration. So allow read if false. There we go. Okay. So I'm going to publish those rules, which are going to say you're now not allowed to do anything. Okay? The only reason I had to add this line is just to make it happy in terms of the syntax. So if I go back to the app now, if I try to run it again, right now it's still showing the data because it's got it cached. It's got a local copy of it. If I try to run it again, you're going to start to see that I'm seeing errors, right? So it still loaded the movies because I had the movies cached from previously, right? but it's saying permission denied, missing or insufficient permission. So I don't have permissions to get the updated movie list because now I don't have permission to read that. Similarly, if I look under genres, I still have the list of genres, but the permissions failed. Okay. So one thing to recognize there is if I don't have those permissions, you may still be seeing data, right, that's left over from before you change the permissions. Okay. So your users might still have data around on their device that they're not allowed to access now. Okay. One danger, one risk. I can also try to change my vote. And you'll see right now, I don't have that permission. I can't change my vote anymore because I don't have permission to write. Cool? Okay. So let me go ahead and wipe the data. And let's see where we get if I don't have those things. So one thing obviously you can see, if my rules are correct, you're not going to get any errors, right? If my rules are too restrictive, then I'm going to get permission denied errors. But if my rules say allow read or allow write, just anybody can do anything, it's not going to give you any errors. It's just going to say, okay, you're fine. You're allowed to do everything. So you do have to be careful there. I'm going to try to run again. Here we go. I'm going to log in. So here's where we're seeing, right, nothing appears. Nothing appears because I don't have permissions. So we're not getting a list of genres to pick from. There's no drop-down built at all because that just straight up failed. So it's still null. And I'm also not getting any of the movies, right? So all of those different requests are failing. It's a good reason to have, error messages set up already to display those things to users, snack bars, etc. Because when you get to this point, it's a lot easier to track down if you have those errors occurring. Otherwise, it can be harder to figure out what's going on. Okay, so let me go back to here and say, let's turn these things back on one by one, or semi one by one. So I can turn these back on. That was pretty easy. I'm going to go back to being able to see all the genres and see all of the movies. But what happens if I do something a little bit different with the other side of things? So let's say I try for the votes. Let's say I'm only allowed to, if I were to say I'm only allowed to get, that would allow me to get a single document, right? So obviously here I'm going to see errors because I'm asking for all of the votes. Remember, I'm asking for all of my votes specifically. Okay? So if I publish this and go back to the app, I need to rerun it because the permissions are still denied. There we go. So this time, movies and genres are populating successfully. But you might notice that my buttons, right, to upvote and downvote, do you see that those are missing? You see those are missing there? So I'm getting denied permission to go view my votes, so the buttons are not there. The reason the buttons are not there is when we set up the adapter, going back previously, when I set up this adapter, down here, line 189 and 190, I said that the buttons are invisible if votes is null, which in this case it is, right? Because I wasn't able to query and get my list of votes, those buttons aren't there. Cool? Okay, so we can play around with that a little bit more. We go back to read, publish. I may have to get it to pull that data again. And this time I've got my votes, right? So I allow the user to read the votes, but notice right now that I can't write them. So it tries to go locally and save that updated vote to my database, at which point it quickly says, oh, I did it. And then it comes back and says, oh, actually we didn't fail to do it, which is why it's clicking back to what it previously was. So I try to make the operation with the database and says, okay, yeah, we'll do it. But then the permission comes back afterward and says, nope, we can't. So those are the kind of behaviors you're going to see if you don't have permission. Does that make sense for everybody? So
Can you explain what just happened there? Because it is happening. Can you explain what these are?
So I click it, right, and it changes briefly. So anytime you try to make a change to Firebase, what it will do first is it will actually update the local database briefly, kind of being optimistic. It'll send out an event to say, hey, update the snapshot listener because the data's changed. Then it will go try to send it to the server. Server says, nope, you can't do it. You don't have permission. So it rolls back the previous change. If I were on airplane mode, go in airplane mode, this is going to look a little bit different. So if I try to go to airplane mode, do you see that there's a different behavior? So the permissions are only checked, these security rules are only checked on the server, not on your client. So if it can't get to the server, then it can't enforce your security rules. So it's going to be like I try to change this data, but as soon as I get back onto the network, that's when it's going to try to send through the data changes that I just made, and you saw all the toast picking up, because it just tried to say, okay, now I can try to send those changes to the server, and now the server responds, oh, you can't do it, and it rolls back the change. Make sense?
I thought you said they were asynchronous. That was the benefit of this Firebase thing, is that you could partially lose connection and it would kind of send it
Yeah. Or in this case, it's kind of queuing up those changes. So like the document sets that I'm doing to cast my votes, it's saying, okay, I'm going to save that because we don't have connection right now, and I'll send them to the server when we do get connection, and then try to do the operation. So I'll do it locally on my local copy of the database, and then later we'll try to do it on the remote. So you can see some interesting behavior when your users are dropping in and out of connectivity. Cool. Okay. So at least things to troubleshoot, right? In terms of working with the rules. So walking back to what we have here, I'm going to get rid of the test one that I put in. Get back to this. Okay. So is that kind of so far? Does this rules that we have now make sense to everybody? Make sense how I got to this set of rules for reading, for creating, for updating and deleting. One thing we'll see here, if I go into here, it's still giving me an error for the reviews, because I'd set up some code previously here to try and get the reviews. It's getting the movie, that's allowed, but it's not getting the reviews because we haven't set up a rule for it. right? So obviously you'll need to set up a rule for the reviews. Cool? Okay. Now, another thing I mentioned is we want to do some data validation. Is we want to make sure that if I'm writing a vote, that some of the data needs to be set, right? So in terms of if I'm casting a vote, what data do I have to set if I'm casting a vote? What data is required? Yeah.
You just call it like value, like vote value.
Let me go look at the deal. So if I'm looking at this document, okay, you can see all of the fields that I have. Movie ID, user ID, movie, value, vote, and home, right? So I've got a total of 5 fields in here, okay? Which of those fields are strictly required? Which ones have to be there all the time? Which ones have to be there?
Maybe the 3 movie ID, user ID, value.
That'd be a good set, right? In reality, all 5 of them have to be there, and I want all 5 of them to be there, but I maybe don't want to be too strict with my security rules because I want to allow some flexibility for maybe code on the client side's going to change. So let me just check the things that are absolutely required for things to not break, right? And so yeah, that would be a good subset. Is we want to say only allow the user to cast a vote if they're setting movie ID, the user ID, and the value. Right? That's probably a good subset for us to say those things have to be not null. So in terms of writing rules against those, I might say, okay, if you're casting a vote, I've already checked that their user ID is correct. I also probably need to check that they're setting a movie ID as well. So I might say request.resource.data.movie ID does not equal null. So I might add that in. And so now I'm getting this behavior that these things have to be correct. I might switch some of these things around. I might say flip this around just to keep it symmetric. So I say, okay, the user ID has to be the user ID of the person that's logged in, and movie ID just has to be not null. I might also say that the value is a little bit more restrictive. Right, so if I'm looking at that, the value has to be either 1 or -1, not just null, it has to be 1 or -1. So I could, with these rules, I could be specific on that and say, hey, value is this, or the value is -1. Now a little bit of caution here. Remember when you're mixing ors and ands, things get a little bit interesting. Remember, ors and ands are not evaluated from left to right. They're not evaluated from left to right. Ands are always evaluated before ors. Ands are always evaluated before ors. So I need to make sure that I put parentheses around that pair if I'm trying to check that it's 1 or -1, right? This is not a case that you'll see in your example because really all I've asked you to check for is other things. You don't really have a value necessarily there. But if I was trying to enforce, maybe these kind of constraints, right? You can see I can do these things. Cool. Questions? So I can enforce schema this way. I can say you can't set it to, you can't create a vote or cast a vote that's 2 because the database doesn't allow you to do that.
In the application, I think you wrote it as long as it's greater than 0 or less than 0, right?
Right.
Okay.
But this would be more restrictive
Okay.
because I maybe have some expectations that I want around the database, Okay. Now, I've only got this under the crate, so I also need to do this under the. I also need to do this under the update. Which might look something like this. Is it starting to make sense to everybody? Okay. Now, you'll notice I have a lot of duplicated code right now, right? I have a lot of duplicated code. So things I might want to do is find a way to not duplicate that code. Remember I talked briefly about functions, right? This is a really good example where a function can be useful because we can say, here's some code that should be common, and so I might want to make a function for that. So I could create a function in here, and we might say, okay, function is valid vote. Okay. And so the things I know I need to check are, okay, if the user's casting a vote, they need to be logged in. So I could put that in there. Or I could just pull in, maybe I'll just pull in those three. So return what is it? Okay, that does have to be there. What is it not liking? Got a bunch of red. Function. Oh, it just says unused function there. Let me try pulling that in where I want it to be. So user is logged in and is valid vote. Okay, yeah, it went away. So it was mostly around the fact that it wasn't being used. So I could condense things that way. I could say, hey, the user has to be logged in and the vote has to be valid. And the good news is I can reuse that same call, say, over here. So if I've got two places, like this often happens, that I need to check that the data is valid in both the create as well as the update methods, I can centralize that code using a function. Cool? That way I've kind of got my schema defined in one place.
Does it matter where you define the function?
It just needs to be here in the same match.
Oh, okay.
So it needs to be within that same match where I'm going to use it.
Okay.
Because I'm referring to things that require that context. So I need to know, is it valid? Other things I might notice as I'm checking here twice is the ownership of that. So I might say function is my vote, and that could be something like return the other part of that. So then I can start combining all these things. Getting this down to one line even. To reduce some of the duplication.
confused here. What changes you made there? Because is valid vote has the my vote logic in it already.
No, it doesn't. Look closer. So request.auth, I'm checking, is my vote is checking if the document I'm trying to change is mine. This is checking that the user ID I'm trying to set it to is mine.
Resource.
So the difference is I need to check both what it is right now and what am I updating it to. That's the difference. One is my vote is checking what it currently is valid vote is checking what I'm setting it to. Cool. So that can drastically cut down on the complexity and the amount of code that you end up having to write and read. And it's really helpful because now these things have names, right? So rather than looking at this kind of mess, I can look here and just say, oh, it's valid vote. I kind of know what I'm trying to do there because of the VIN mode. Cool. So that's going to prevent a lot of other just bad behavior where maybe somebody's trying to cast a vote for somebody else. Now you can't do that. If you're trying to maybe cast a vote that's not 1 or -1, you can't do that anymore, et cetera, et cetera. Any questions? Okay. So take a look at the lab assignment. What I want you working on finishing up today and tomorrow is you'll look at phase 8. And so with phase 8, what I'm asking you to do is limit the access to the database using these security rules, right? So I've talked about what specifically I want you to do. So by default, the default is that things should be not allowed. In terms of the games collection, I should be able to read any game. And actually, I should mention that on the consoles collection. You should be able to read any console, but not write any console. So that effectively is read-only data from your perspective, from the user's perspective. Same thing with the games. They can read them, but they can't write them. They should be able to read their wish list and their reviews. They should also be able to read the user profiles. So we haven't really, if you have additional data for, say, your user, that would be in the users collection. We're saying, hey, you can read any other user at this point. And then writing, we're basically saying you can only write your own data, right? You can write your own data. I've asked a little bit in terms of protecting this data. Cool. Cool. So that's all I'm asking for is phase 8 is to just write some rules that satisfy those needs, that enforce the schema. Okay.
It's not too hard.
Not too hard.
Phase 8's pretty easy.
So